The equation for direct variation looks like y equals kx, where k is called the constant of variation. So for example, if we have y equals 3x, then k equals 3, and that's the constant of variation. If y equals kx, then another important idea emerges, and that is that k is equal to y divided by x. So, for example, if we wanted to say find k, we could find k by dividing y and x in that order. Let's take a look at some examples of direct variation. So here we have a table of values. Let's see if y varies directly with x. So we should be able to divide y and x, and let's take a look. 2 divided by 1, 6 divided by 3, and 8 divided by 4. And hopefully what you see here is that they all equal 2. They all reduce down to 2. So we say the constant of variation, k, is equal to 2. Remember that k is equal to y divided by x. So the equation that links y to x would be y equals 2x, where 2 is our k, our constant of variation. Here's an example where y does not vary directly with x, and let's take a look at y. Remember that k is equal to y divided by x. 4 divided by 1, 8 divided by 2, 11 divided by 3. And here we have a problem. These two reduce down to 4, and 11 over 3 does not. So all three of these points do not vary directly. We didn't get a constant of variation, and that was the key here in our first definition. It's a constant of variation, and so we saw that happen here, but not here. What about if we're given an equation? Well, I'm going to divide both sides by 3. And here all we're doing is checking to see if it looks like y equals kx. So here we have k equals 7/3. So the equation that links y to x is y equals 7 over 3x. Let's take a look at an example that doesn't vary directly. Once again, I'm going to solve for y. But you can see that this doesn't fit the mold. This does not look like y equals kx. It looks like y equals kx plus 1, but that is not constant of variation. So let's do some other problems. Suppose y varies directly with x. What is the constant of variation? So y equals kx, and therefore k equals y divided by x. And we're given two values. Y is 32 when x is equal to 2. So k must be equal to 16. And if k is equal to 16, then we should be able to write the function y equals 16x. Let's word a problem slightly differently. Suppose y varies directly with x. Y is 9 when x is negative 15. What is y when x is 20? So once again, y equals kx. Therefore, k equals y divided by x. And I'm going to first start with this piece of information here. And I'm going to get 9 divided by negative 15. Well, we want to know what y is when x is 20. So the first thing I'm going to do perhaps is reduce this. 3 over 5, dividing both of those by 3. And if y over x is negative 3 over 5, then I can set that equal to and create a proportion for x is 20 for an unknown y. So I can then solve this proportion. Now let's do that. And I'm going to simply solve this proportion by recognizing that I can multiply that by 4, and therefore I can multiply that by 4, and therefore y must be negative 12 when x is 20. Let's do that same idea in a word problem. So we have current varying directly with voltage. So let's set up a little equation here. Current varies directly with voltage. Just like saying y varies directly with x, in this case I varies directly with v. Therefore, K is equal to I divided by V. So next we're going to get some information. 12 volts, 4 amps. 12 volts, 4 amps. That reduces down to 1/3. So I over V equals 1/3, and then we can set that equal to, we're given volts, which means we're looking for I. Six times 1. I equals 6 amps. And finally, let's graph a direct variation problem. We can do this by simply plugging in some values. I'm going to plug in negative 4, 0, and 4. So, plugging in 4, 3/4 times 4, that's going to give me 3. The second one should be really easy. That's going to be 0. And actually, it looks like I plugged in positive 4 there, and I'll plug in negative 4 here. So I don't have to go back and erase. And that'll be negative 3. So positive 4 makes positive 3, and negative 4 makes negative 3. And then we could simply graph these values. And that's what that direct variation looks like.